Good morning, everybody. It's almost 9:10, so I'm going to get started. Happy Friday. Welcome to class. You might have seen I sent out a post. Usually we have a post after class, but this time I did before class. So you may join a little bit early today because I want us to get started sharp at 9:10 and use every single minute we have. We have a guest lecture today, and this is going to be given by, you've been seeing the display so far, by Dr. Ofer Amram, who is an assistant professor at the Department of Exercise and Nutrition in the College of Medicine. And I'm going to say a couple words about him and how I came to know him and why we are having this lecture. But for those of you who have been wondering what people are responding to, and this is also a little bit of a guide to offer on how we operate here, we start our day with a warm-up question. And because of the relationship that it has with the lecture we will have today, I've asked people to tell me where they grew up in, the name of the city and the state. And if it is outside of the US, then it would be a name of a city and a country. And hopefully, if Ofer is going to be up for the task, the chat analytics for this one is going to actually be a map. And so we see the class of 475, 575, class of 2020, is like this, is what it is going to be. We can get it maybe on Monday or maybe before that, and that will be a lot of fun. So we have started for the benefit of Ofer, talking about data visualization. That is the topic for what we started this week. We did an introduction lecture on Wednesday. We have a follow-up lecture today, and we will have a couple more visualization topics next week. Ofer is a collaborator of mine, a good colleague of mine. I have been interacting with him on a number of different fronts. He works in an area that is central to the topic we have now, visualization, and especially things that would involve having to work with the web and in an interactive fashion. He did his PhD at Simon Fraser in Canada and spent as a postdoc at the University of British Columbia, and he's now at WSU. And so there may be some chances for which we would get some project ideas from what he will be working on, but he works in an area that has got both visualization and health-related epidemiological issues. He will talk about his work for the rest of the time. What we will do is, if we have questions, we will put them in the chat. And I am going to hope that there will be some 5, 6, or 7 minutes left towards the end where Ofer will get a chance to answer to those questions. So instead of interacting, we'll put questions on the chat. Ofer, the floor is yours. I hope you can take control of the share screen. And when you are ready, please go ahead and do that. And Ofer's slide will be available on Blackboard after the lecture is over. So if you want to take notes, take them note the old-fashioned way on a piece of paper. All right, welcome. Okay.
Hi, everybody. You guys see the slides?
Yes.
Okay, great. Yeah, thank you so much, Asafa, for the introduction. For a second, I thought this is for the name of the city and state. This is where everybody is logging to this lecture from. So I was like, it's still exciting to know where you were born, but I was talking for a second, thought I was talking to the world. So let me quickly introduce, thank you, Asafa, did introduction. I'll get to it a little bit in detail more. Assistant professor, I'm an assistant professor at the College of Medicine. I am a special epidemiologist in nature, which means I actually have a dual degree in geography, PhD in geography, and a PhD in public health. So we bring geography and public health together. Also, when I arrived at WSU 2017, I started the Community Health and Special Epi Lab. And more importantly, the type of research we're doing is really trying to understand the relationship between space and health, where we live and how it's impacting on our health. And that really can, can play itself in different ways, either through socioeconomic status or the actual physical environment. And a lot of the research that I do ends up with some sort of visualization in the end, and that will be the topic of today. But just quickly before I jump into the visualization part, let me just go a little bit about the research I do that may actually be of interest to you all, because it does involve a lot of big data analysis and some ideas from computer science. So when we try to understand how the environment influences our health and wellness, we typically look at things in the environment that obviously directly impact our health. So that could be air pollution, noise, exposure to green space, how walkable our neighborhoods, and obviously the neighborhood socioeconomic status. And that's essentially, this is a whole field that is called exposure assessment. Okay? But how we actually doing it different ways, but one of the ways that we are doing it is actually we're taking a subject that we want to study their health, and we give them GPS, accelerometer, and
Ofer, I'm going to ask you if you could, so your audio gets on and off occasionally, and I thought it was only me, but I think other people are noticing that. So I'm not sure if there is anything you can do to make it stable.
Okay, maybe I'll get closer a little bit, maybe it's something with the distance. Let me know if it's still a problem. So, like I said, we get people to wear GPS, accelerometer, and we get them to basically just do whatever they do, live their life. We typically do it for a period of a month. And then through the GPS and accelerometer, we know where they are. We calculate the type of physical activity that they do. And then we sort of relate it to health outcomes, right? So as you can imagine, wearing a GPS for a period of a month will produce large amount of data. And this is sort of where a concept from computer science and engineering, data manipulation, data science really comes into play. The problem with working with GPS data is that we kind of, we only have one period of a month to assess exposure. So now we move it, and this is a project we just got funded to, is to actually use Google timeline to understand exposure over a really long period of time. And obviously this data is collected passively through your phone. So Google timeline is collecting data since 2012. So now we get, 8 years worth of data, and now we can understand how changes in behavior, exposure actually related to health outcomes. So whether if you ran for a period of 6 months, did it impact your BMI, et cetera, or your chronic disease. We also use quite a bit of Google Earth Engine, which is a platform to assess exposure through satellite data. So just to give you an example, a study we're looking at whether the delta between minimum and maximum temperature prior to getting a heart attack has influence on the likelihood of getting a heart attack and dying from it. So we're taking for each person who died, we have their location. We're measuring temperature from over a period of 1 day prior to that up to 7 days. And we're looking at that because we know there is a causal relationship. So the colder the temperature and the bigger the delta, that may actually impact your blood flow, for example. So we use Google Earth Engine for that. We also use analysis of Google Street View through location. So when we know your location, we extract Google Street View images, and through manipulation of the images, we understand the microenvironment where you were sort of hanging out. So it's green space, blue space, et cetera, et cetera. So this is the type of research that I do. And like I said, in the end, most of the research that we are doing in the lab, we end up with some sort of data visualization, and that essentially will be the presentation today, the focus of the presentation. This is sort of my colleagues in the lab. I typically do the visualization. That's why I'm here to actually present that. But really, most of the science and research that we do, the visualization is just the end part. We do a lot of modeling prior to that, and then we essentially. So this is sort of a visualization of a definition of what visualization. I feel like this is a definition which essentially say we're taking data numbers and we manipulate it in a way that it's easier for us as humans to understand trends within the data. So even creating a graph in Excel is a form of visualization. But visualization has other techniques. It's not just graphing and charting, even just playing with color coding and opacity is a form of visualization. So if I'll ask you to count me the number of 8s in this series of numbers, it will be really difficult for you. However, if I'll display it this way, that's a form of visualization that now allows you to really understand the patterns of 8 within a series of numbers. So visualization really brings many different techniques into play, and I see visualization as a combination of science and art. So, and we will focus here on sort of web mapping visualization, and more sort of like interactive data visualization, which refer to the innovation use of images, interactive technology to explore large, high-density data set through graphing, dashboard, and maps, which will be the focus of what we're doing today. And increasingly, large data sets are becoming a big part. So what do we need to do visualization? It's essential for us to even start doing a visualization, would have data and preferably really good data, right? And through the data, we can tell a story through a visualization. You can optionally, if you do sort of modeling before, you can have an analyst, optionally designer, but you really need to experiment a lot of visualization, and there is no one way of visualizing one thing. I can show you visualization of the same data set different ways, and people have different opinion of what is good and what is not good, right? So this is sort of the art part of that. That's why I require a lot of experimentation and getting other people to give you input into your visualization. In terms of knowing your data and analytics, there's different level of analysis where visualization can play a part, simply describing data, doing some modeling and displaying the results, doing some predictive analytics, and also doing some scenario-based modeling where you, for example, if you put a health facility somewhere, what will happen to access to healthcare, how it will increase life expectancy in the area, for example. So you can do more advanced modeling. But again, visualization can really play a part in any of those stages. Like I said, we'll focus on mapping, but a lot of the visualization mapping, bringing together different type of visualization technique into the web mapping platform, a lot of mapping, including graphing as well. I use a lot of text within my textual visualization technique within my mapping. So you bring different tools into your visualization, tools and techniques of visualization. I like to bring historical context into sort of the idea I'm talking about. So let's just focus on why mapping is important in health. Anybody familiar with this map? This is probably the most famous map in public health. And the story behind this map is that in 1845, there was cholera outbreak in the Soho neighborhood in London, and in red dots, that's basically all the location where people died. So Dr. John Snow, that's called the John Snow map. He basically went and mapped, those are the red dots, all the causes, all the deaths that occur in the neighborhood. He then plotted all the water pump in the neighborhood. This is back then where you got water from the water pump at the neighborhood. And he basically realized that, and that's the water pump, he basically realized that the water pump is contaminated, and that is causing the outbreak of cholera in the neighborhood. He basically shut it off, and the outbreak was over. This is a sort of a heat map that I created using those red dots. And you can beautifully see how all those cholera deaths are actually centered around the water pump, right? So a simple map can tell you a lot, right? And this is where people started to realize the power of mapping in the context of public health. But now we have way more data available. We have technology, computer, web mapping technology that now allows us to do way more with our data. So through web mapping, we are visualizing location-based information online. It's typically very rich with functionalities, large amount of data, tend to be dynamic. And the advancement of web mapping is really so rapid, especially in recent years, that it's a continuation, it's a learning. We continue learning new things and new technology coming up, and we can do new things. But how web mapping typically works, we have the data stored somewhere on the server, and that can be a DB data, CSV files, whatever that may be. And then we essentially present it to the browser, and on the browser, we can work with the data and do manipulation with the data. Different technology some web mapping technology has most of the functionality, and the data itself are on the server, and we constantly going back to the server to ask for the data. Some technologies are, a lot of the data is actually the client side in the end, so the interaction with the data is easier and faster. So what do we learn from web mapping? Where am I? What am I? What's around me? How things changing over time? How close are things to me, and how this closeness has an impact to, for example, my health. And again, we can do quite a bit of more. Data is really the key here. I can't stress it. You really need to know your data before you do any visualization. So whether your data is, and I'm sure you went over it, so different type of data we have, normal, ordinal, interval, ratio, and what you can do with that, right? So categorical variable typically are qualitative in nature, and so the color coding, right? When you're talking about quantitative, which is the interval and ratio, the calculation and the visualization. Plot your data is really, really important. Before you do any visualization, you have to understand how your data is structured. What are the natural breaks within the data, and that will impact how you want to visualize the data. Color coding is the key. Knowing your data is again coming into play here again. So if you have a ratio type of data from 0 to 1, typically are going to color coded using sequential color coding. If your data stretch from minus to plus, then you want some sort of a divergent scale where the minus will be typically around the sort of the midpoint here, and categorical values are typically just simply standalone colors. So knowing your data and how it's displayed is critical. And as a scientist, when you do web mapping visualization, you have to understand you have a lot of power in your hand to really impact on what the viewer is perceiving in terms of what's going on. Okay, so how you color coded, the number of classes, the way you shape your colors can really impact what the viewer thinks about what's going on. As a scientist, we have a responsibility to give as accurate information as possible, and if we cannot, then we can never give. I mean, web mapping and modeling is an abstract of what's going on, so we will have to simplify things in there. We'll have to essentially address that. There's actually a really famous book that essentially that shows it's really easy to lie with map and manipulate what we are thinking about what's going on through map. And this has become really difficult when we're talking about working with huge amount of data. Okay, so we have to think about all those. So I'm going to take you over step by step on how we created our latest sort of visualization, which is a COVID tracker, which is updated daily. And it's essentially give the states of COVID for each country across the US. And we will go over it. Give me a second. Do you guys now see the presentation again? Okay, I will sort of jump up between my browser. So this is the tracker. So this is how the tracker looks like. So this is essentially how the tracker looks like. So the tracker.
We are looking at your email now.
Oh, okay. Are you sorry? Are you seeing? Okay. This is the screen that I'm sharing. So,
now we are okay. Now we are
okay. So this is essentially the tracker. Let me reload it. But the tracker essentially, like I said, gives updated information on what's going on in terms of tracker across the state. And for us, we are pulling the data from the New York Times. And for us, we wanted to really make sure that our tracker is not doing what other COVID tracker are doing. We want to distinguish ourselves in terms of our tracker and have a very specific message in terms of visualization. So New York Times scrape the data every day. It takes a lot. There's like 30 people working on it. I don't have the capacity to do that. But my tracker actually has a different focus. So I simply get the data from New York Times, but my focus is rural-urban differences across the United States. And that's the focus of this tracker, using exactly the same data as the New York Times. And this is one of the sort of messages I want to bring when you do visualization. You want to really distinguish yourself and have a clear message for the tracker. A visualization cannot, it's very hard for visualization to answer all questions. So your messaging should be really focused. So our tracker, and I will go over it quickly, have many elements, but all of them focus on rural-urban differences. So we're loading the data, we're graphing rural-urban differences, metro, non-metro here across the US. If you over a county, we recalculate the curve again, and sort of giving you a curve for the county, comparing to the sort of state level and the national level. If you click on it, you get whether it's urban, rural, and how it's really sort of stands out compared to others. In a lot of my visualization, because I do rural-urban differences, I want to make sure the viewer can see very global view of what's going on and a really focused view. So I have two windows, one which is focused on the small area you're interested in, but also give you focus around. So I have an interactive inset window. So we can look at weekly change as well across the county. We can do analysis by state as well, and urban-rural differences, where in red, we see states where rural are much higher than urban. So everything is really focused on the message we want to convey, which is rural-urban differences. Like I said, I had to distinguish our tracker from other ones. So this is a really important concept. So let me sort of delve into sort of the technical aspect of that. So when you do a visualization, you really need to start first planning the visualization and really think about how you want to do it, work on your spatial data for the web mapping, manipulate the data, get the non-spatial data, the value of COVID in our case, clean the data and really have a clear pathway and a roadmap on what variables you want. And in our case, that was sort of rural-urban differences, summing by counties, summing the counties by rural-urban and doing sort of population, cases per population, a rural-urban level, comparing them to the state level, comparing them to the US level. So there's a lot of data preparation there, okay? And then we simply visualize this data. So let's go step by step. So planning your visualization, I actually simply do it on a whiteboard and kind of do a sort of somewhat a pseudocode roadmap and how I want the data flow to be. And this is really helped me to start my visualization.
Ofer, do you want to go back to your big screen mode, or do you need your?
Let me say, because I will.
Okay. All right. Perfect. Perfect.
It will be much easier for me at this point. I can make it a little bigger.
You're good.
First of all, when we do web mapping, we need to get spatial data. So for us, spatial data coming from the US Census, which you can simply go and download the data. I first use, I'll show you how the data looks like. This is how the data looks at after it's been downloaded. This is in ArcGIS and plot. But when you want this data on the web, it cannot be in this format. It has to be in either a topo.json or a GeoJSON format. So these shape files that come out from the census needs to be converted. And the way I use topo.json, it's compressed the data up to 95% smaller than GeoJSON. This is really important aspect when working with sort of web-based spatial data, okay? And there's different ways to convert. I'll show you how to do it. It's a software, it says you can do it online with a software. You can do it online. There is an online, essentially, portal that allows you to grab the shapefile. So I'll show you actually how to do it. So I'll just give you an idea. So once you download the shapefile, and this is how a shapefile looks like. You can simply go and grab it, drag and drop. And this is a really important step, simplifying our data. Why we want to simplify our data. So this is how the exact shapefile look. And for our purposes, this essentially shapefile has a lot of information that actually will be useless for us, and we want to remove it because we want our file to be as small as possible to load really quickly on the web. So to simplify it, we just check this. We can go over and see what simplifying does. Can you see that? That we're removing features that are unnecessary for our visualization, okay? You can, if you go extreme, it's completely morph the shape. So you wanna keep it, give it still a view of the counties, for example, but reduce the size to 26% of the original size. Then we can export to GeoJSON or export to a TopoJSON. And let me quickly show you. That. So this is 1 mega. This is 500 kilobytes, and the GeoJSON is essentially 1.1 megabyte. This is 50% reduction in size, and this doesn't look a lot, but you really want to keep it as small as possible. So that's a big difference. This is 50% between TopoJSON and GeoJSON. So I would highly recommend working with TopoJSON, but not all web mapping technology support TopoJSON. Keep this in mind. So now that our shapefiles, our spatial data is ready, we need to go and get our COVID data, which every day I basically download from GitHub and I automatically display it on our web. So on our tracker. So this is a CSV file showing how the New York Times data on COVID cases look like. So you have COVID data for each counties since March 1st. This is up to yesterday or the day before, I don't remember, but you get cumulative number of cases, okay? And this is what's actually is being loaded. This actual data is being loaded to the tracker. But if we go back to our tracker, we'll see that our actually values are daily cases, right? So our starting point of CSV will require quite a bit of manipulation. And first of all, is actually convert this to daily cases as opposed to the sort of cumulative cases. So you really have to think about each step on how you're going to manipulate this data and eventually how it's going to display, okay? So have a roadmap of how you want to do it. And essentially once we do it, if we go back to the tracker, that's essentially what we get. And from that CSV file, I essentially, every morning, I essentially go up I have another loader. I basically get the data. It's right away is loaded into the file in my server, and I format it, and then it's basically uploaded on daily basis. So essentially, this is the track. So let me just go back to my presentation, and I think at this point, any question on this point on that one?
So maybe you can, if people have questions, they can ask now. I guess if this is a good transitioning point.
This is a good transitioning, yes. So if you have a question about all the technical aspects, I'm happy to answer.
So this is a place where it's allowed to unmute yourself and ask. I haven't seen any questions on the chat session. So let's give people 30 seconds or so if they want to ask any questions.
Okay. So building is...
So there is a question that just came. Brit is asking, how do you pick between data sets? Like for COVID, there is a lot to pick from, and how do you choose what to do, which data to pick?
Well, that's a good question, but that's in your plan. So you really need to think about what do you want to show. So for me, because COVID data, updated COVID data is really, really important. Updated COVID data is really hard to come by at the national level, right? So I have very few options of what I can do. Okay, so essentially I had one option, and is essentially the New York Times data, this updated daily, county level, nationwide. There's a couple of other trackers using this data. So I looked at this, I essentially found the gap and in terms of trackers about what's showing up. And for me, it's natural to do urban differences because we do a lot of research about it anyway. So in terms of choosing the data, it was pretty easy in the era of COVID because at the scale that we're looking at, the resolution I was looking at, there's very limited choices. Is that answering the question?
Yeah, so you did not have that problem of which data to pick from because you had only
Exactly.
limited. And where was it coming from? The one that you actually use?
The New York Times, the New York Times compiled the data daily and they post it on GitHub.
Right. That's
what
a good answer.
I say is that we had to bring other data sets. So we had to bring population, because this is cases per population. So county level population. We also have number of hospital beds per county. So additional data coming in that we can join to our, essentially everything is joined by the county ID and all the calculation is done on the fly. Mm-hmm. Okay. So experimenting is really, really important actually. Maybe I'll show you later on if I have time a little bit about how even experimenting with color coding makes a big difference even in our tracker. So if I change one value in the way I classify my code, the value of coding is really, really, can really change the way we see the tracking, okay? So experiment with it. For us also, you have to think about what are those values classification. So if you go on a tracker, there is info on the classification in how we classify it, because there is some cut points where we know infection rates for COVID are gonna go down, okay? And this goes into how we classify data. So for our example, it was really important to classify those low value based on some medical expert on what they say infection rate is spreading. So when we show the map, we show, okay, which counties are at the level where where the spread is going to be very, very low, okay? So always think about, especially when you do it in health, what are those values actually represent, okay? Know your audience. I cannot stress this. You can create an amazing visualization, but if your audience is just the public, so please do not put odds ratio, do not put, you know, scientific terms that the audience wouldn't understand. So knowing your audience or making a visualization for professional or for the public should look different, okay? Simplify the data, have a focus, and stick with this focus, and all the analysis should really channel for what you want to show, and for us it was rural-urban differences, okay? In terms of technology, obviously we do use, I mean, there is server-side web server, again, spatial databases. In the web, you're always going to end up as GeoJSON, okay? But you can load it as JSON, which is going to be much faster and smaller in size. Obviously, a lot of HTML, CSS in terms of designing. SVG is understanding SVG and how to manipulate SVG and essentially do a lot of visualization. Using SVG is critical to do web-based visualization. And obviously JavaScript is essentially the language you can use. I use a visualization library called D3, stands for Data-Driven Documents. There is a link for it, I think in the site below. So, yeah, right there, so you can go. But if I have time, we can go over it together. It's really powerful. It doesn't look like the typical JavaScript in the beginning, but they design it in a way that your arrays or objects are really integrated into the DOM level of HTML and the SVG, so it's really easy to access, manipulate your arrays and objects. Other software that do visualization, the famous one is Tableau, but this is sort of out of the box visualization software, and there's other sort of online software too. So what I want to do now is do a little exercise that will show you essentially data visualization. Just a quick data. I did it like 3 years ago when I worked in HIV. There was HIV treatment that completely changed how people survive HIV, and sort of morbidity and mortality. It came in 95. And we wanted to visualize the impact of this treatment on essentially mortality and morbidity. And I want to show you a visualization that showed that, and then we're going to go over the actual data that's used to generate this visualization. So here we see, this is the first, so those arcs represent the life of a person, life expectancy estimated at 80, and the blue dots show when they die, okay? And here we're now going to start to see all the people who died since 94, 95, we had antiretroviral therapy coming to play. And now we're going to see how life expectancy are essentially increasing because of this visualization, because of this treatment, sorry. So this visualization is interesting because it does actually bring into play different elements which, you know, can really impact our emotion a little bit with these people dying. But what do you think, if you look at those elements, what do you think is really driving this entire visualization? It's actually really simple 2-column data set that drive the entire thing. So let me go essentially, I'll show you what's driving this. Again, let me just quickly come to the end. Sorry about that. I need to learn how to reopen it. So this is the only thing that drives this entire visualization is this 2-column data. Okay, the age of death and the year the person died. Okay, so we'll go one by one a bit each element of this visualization and how it's actually calculated from this entire data set, from this actually really small data set. So here we see we get the raw count of death while, you know, as this visualization animate. We get the year, we get the lost years, and I think this is a concept you learned last week in IHME, essentially how many life was lost. If you died 30 and you're expected to live to 80, you lost 50 years, okay? We do have the arcs, also color-coded based pre and post, the interventions, so, and they're also color-coded based on you, until the point you lived or died. We have an animation which, you know, let us see the impact of the treatment, and also graphic summing by year each of these interventions. So we have death per year, and we also have an average death per year. So this is a really nice illustration how, and I must say, I mean, I created all this, but that concept I saw some other place, but I didn't have all the intervention elements, just have the arcs. But I sort of took this idea and built all this thing around it. But this is a really nice way to show how really simple data set can create quite rich visualization, right? So you really need to know your data, really critically think about it, essentially, you know, draw all the different variables you can squeeze from the data, essentially, and try to create a story around it. So with that, I will sort of end this presentation. I'll be happy to take any question you have.
Thanks, Ofer. That it was great that you left some time for discussion. It was a great presentation. So let me give people a chance to ask. And if you have questions, you can put them in the chat and I will read them as they come. And there's already one question that came. Chris is asking, when you started, did you know what you wanted to visualize beforehand, or did you figure out after looking at the data? Which one comes first?
Yeah, I usually have a general idea of what I want to do, right? But it evolves. Every time you do a visualization, it will evolve because you're gonna, and this is where I'm saying, know your data offline with Excel, with R, plot the data, know the trend within the data, know what's really important to show, you know, obviously focus on the message you want to show and what trends within the data will really highlight that message. And that focus, everything should focus around that.
So there is another Chris in the class who is asking actually on the visualization that you're just showing now.
Yes,
yes. The display, and he's asking what the height of each arc represent in your HIV visualization. The height
yes, yeah, it's a great question. The height is actually, if you notice all those small curves, people died early, right? So they essentially related to when a person died. So the arc is bigger if the person died much later. Right.
So you did say know your audience when you have visualization and you've got a lab chase, and Brit is asking who you consider your audience to be as a lab. Who is your audience? You know, that's a great question. If I actually would like to show you in the lab the way I rarely do visualization by itself. Okay, so if I get one of the reports we did. My visualization is always in the context of some research and text. So if I write a paper, I later do a visualization, I always create a summary reports around it, right? So there is a story, there is some text. So if for example, I want to focus on diabetes, there is a stories and text around it for you to read, but then you can always go and work with the data to explore more. Right, so for me, the audience is generally the public, right? So if I always have, not always, most of the time, video tutorial, how to play with that, take it to sort of a YouTube video tutorial. I have a lot of sometimes I will have sort of eye points, will give you information about what each function does and things like that. So I try to do my visualization both for the public and both for professionals. So it's actually a lot of professionals are using us to explore data, right? And understand trend, and then they can, bring, more treatment to certain location and things like that based on disease. So professionals are actually using it, but because we do a lot of description before, the public can read, and actually a lot of media are picking it up because they can read it, understand it, and they can play with the data, and they can come to us with questions. Would policymakers be included in those professionals? Definitely, policymakers use it a lot. Yes. And as you can see, for us, a lot of my local map in Washington State will have those inset map because I focus on rural urban differences. And for me, it's very essential for the audience to understand what's going on in the very busy sort of urban area, Seattle, without zooming, and really understand what's going on in the rural area at the same time. So I always usually like to use sliders because one of the limitations of classifying data is that you hide very small variation. But with a slider, it allows you to sort of understand what are the really high location, either in Eastern and Western Washington, to give you a lot of control on the data. So if you really want to do in-depth analysis, you can actually do that. While you're there, can you comment on what it takes and what advantage you would get compared to, off-the-shelf things like what Tableau would do, or some things that would not require a lot of programming on your part? What's the advantage here? I have a lot of, I would like to have complete control over how I visualize everything. And I mean, Tableau has its own look. It's very structured. So if you go back to the tracker, right?
I never worked with Tableau, but I started with the very raw data and I simply dump it into my folder data and everything is done by the code. In Tableau, you will have to format everything for your Excel file for the different data sets. From this data set, I create probably 10 different data sets through code, right? Mm. There is a balance. I mean, for me at this point, it's much faster to load and interact if you're doing it this way, as opposed to like 10 different data sets.
Right. All right,
and from a visualization perspective, I do have way more control about every little aspect on it. And if you see Tableau slider, every time you change, they go to the server, get the data, visualize. Here, everything is on the cloud and much more responsive as
well. Right. We have got to stop it there. Thank you very much, Ofer, on behalf of the class. This was really, really helpful and awesome. And I'm going to have the slides posted when this one is over, but yours was much richer and a lot more helpful to have these demos, and I appreciate that very much. The recording will be available when Zoom makes it available, and I'll let you know. You have indicated where you come from, and we will see what we can do to turn that into a map, and it will be a nice visualization someday.
Yeah, I mean, if you, I don't know if you want, you can, but you should capture all those locations somewhere.
So what we do usually is when the class is over, I go over this and try to find some way to summarize whatever it is that we chatted about. This time you will get a list. You'll get a list and you will show us what you will do on the map. And that will be really awesome. And we'll remember you for a contribution that will stay with us for a long time. So on behalf of the class, thanks again, Ofer. If there is a project idea that comes out of it, some of you may end up working with Ofer for your semester project, and it can happen. But I know there are some who would need to go to class after this, so I have to stop it here.
Thank you very much.
Yeah, thanks again. And I will see everybody on Monday.